Hey guys, so far we have looked at a few interactions between acids with some other compounds like metals, metal carbonates, bicarbonates. We also looked at one instance of a base within a compound. Today what we look at is we look at what happens when an acid and a base interact with each other. Okay, now to help me understand this, I will be using a couple of things which we'll talk about in a bit. But before we start, again, it's an activity. So make sure you are taking down your notes in an activity format. Okay, so aim, apparatus, procedure, observation, and the result. Right. So for this, the aim is to observe interaction between or the reaction between an acid and a base. These are called as neutralization reactions, and why they are called so we'll be figuring out in some time. Right, so the equipment I'll need, mainly I'll need my two chemicals, acid and a base. In this case I'll be using hydrochloric acid and sodium hydroxide base. Alright, now I filled both of these containers with the acid and the base, just it's easy for me to use. This is the base and this is the acid. Along with these two beakers I have my indicator here, phenolphthalein. So if you recall the first class of this chapter, we spoke of phenolphthalein as an indicator that will help us identify which one is an acid, which one is a base. So to figure that, I know that phenolphthalein turns pink whenever I add it to a base. So what I'm going to do is that, right? I will be first adding my indicator to my base to check whether it's a base or no in the first place. Okay, perfect. Now I'll be adding this indicator to this base. I know base is present in this, so there it is. I just added a couple of drops and you can see a nice pink hue to my solution, right? So I know now that whatever is in this is a base. Okay, that is my sodium hydroxide base. What I want to do, I want to slowly keep adding acid to this base and see if anything happens. Okay, so I'll add some acid here. You'll notice that the moment the acid touches the liquid, it becomes white for an instant and then it again becomes pink. Okay, just keep watching. There, momentarily it becomes white. If I mix it up, now you'll see that all of my solution has become colorless. Okay, if I add more phenolphthalein also, it's just going to show me this colorless. It's not about how much phenolphthalein is there. Now we know that phenolphthalein shows us the content of whether it's an acid or a base, and we know that colorless definitely means that it is an acid, right? Now this base, I've slowly kept adding acid until it became colorless. Okay, this tells me that now the base and acid have reacted with each other. Now if I add back my base, watch the color of this liquid now. I'll just add a little tiny bit. There. If you see now it's slightly pink. If I mix it up, it's just going to go again. I'll just try to keep adding until I regain the pink color. Okay, the moment the base touches the indicator, it becomes pink, but since it's reacting with the acid, that pink color is going to go away. So we'll just do this a couple more times, and now the solution has become a base again, which is why the pink color is dark and prominent now. Okay, now if I add back the acid, we'll again see the same thing that happened, right? Now I can tell you that the acid is many times stronger than the base, which is why just a little bit of acid is turning this quickly colorless. Right, so what happens when an acid and base interact is they cancel each other out essentially. Okay, so acids and bases are pretty much like on opposite ends of a certain chemical spectrum, which we'll talk about later anyway. So when an acid meets a base, it neutralizes it. When by neutral I mean it's not an acid or a base anymore. Okay, so this reaction gives us a salt and a water. Okay, so every acid that reacts with any base is going to form some salt and some water. Depending on which acid and which base, the salt will change, the water stays the same. In this case, we have hydrochloric acid and sodium hydroxide, NaOH and HCl. So NaOH plus HCl give me NaCl and H2O. So this is a liquid solution of a salt. The NaCl is common salt, the table salt that we use. If I get my mixture right, once I add an acid and a base, if the mixture is perfectly neutral, I can even touch it and nothing will happen to me because it's just salt and water. Right now I will not take the risk because I haven't measured out exactly how heavy the acid or the base are and I can't really tell. So that is why I will not take that risky test. So this is what neutralization reaction is about. Acid and base reacting to give salt and water. We use the phenolphthalein indicator to help us figure out whether it is acidic or basic. We can use other indicators also. We can definitely use methyl orange, and if the final solution, if I use the litmus paper, I'll be able to tell whether it's acidic or basic. If blue stays blue and red stays red, that means it is truly a neutral solution. All you need to take away from this class: acid base reacting to give salt and water. That is all for today. Thank you so much. I'll see you in the next one.